Ladies and gentlemen, greetings to all participants of the conference. Let me present to you the research on the topic Commun's clustering method in organizing passenger transportation in a smart city, made by Yurii Matseliukh, Vasyl Lytvyn, and Myroslava Bublyk, namely from Lviv Polytechnic National University. With the increasing complexity of urban transport system, clustering methods for big data analysis are gaining popularity in smart city passenger transport management. These methods contribute to improving efficiency, adaptability, and environmental sustainability. The levels of the study are determined by the growing volume of transport data, the necessary to adapt of changing demand, and the need to minimize the negative environmental impact on the transport system. The purpose of the work is to study the possibility to using the Cummins clustering method in organizing passenger transportation in a smart city and to determine the feature of their application to optimizing the organization of passenger transportation by public transport, to analyze a large-scale heterogeneous data set on the duration of electric transport trip within the average size city, to propose clustering selection algorithm based on clustering quality assessment metric including the elbow method, the silhouette method, and the Kaczynski-Harabash index. The object of research is the process of clustering dataset of the organization of passenger transportation in smart city. The subject of research is the principle of optimizing passenger transportation in public transport and improving the implementation of their transport schedules. Dataset has the following structure: recount number, geozone, planned arrival time, actual arrival time, month, date, time, date, week, hour, day of the week, working and non-working day. The total volume is equal 890,999 record. After cleaning the data from empty cell, separating incomplete, additional errors and information failing out the general time frame of the duration of operation of vehicle on the route is equal 716,860 record remained in the dataset, where the appearance of the first 21 records is shown in the figure on the slide top. Average daily duration of each journey by vehicle of each week are presented on the slide in the figure on the bottom. An analyzing of the heterogeneous data set of the duration of electric transport races in average sized city. Using the Python pyplot tools from the matplot library, we visualize the average daily duration of the section 1, section 2, etc. race by vehicle for each week, constructing the graph shown in the figure on the slide. Frequency characteristic of the average daily duration of the section 1 run by vehicles is presented on this slide on the left part. Using matplotlib, a graph was generally with V on the X rate and race time in seconds on the uh, y-axis for each of the rates from section 1 to section 10. The research also used a box plot for all sections, which show us the statistical summary of the distribution of race time for each section for the road, highlighting the media, quarterly, or outlines. They are presented on the slide. The analysis of the data set is shown in this figure. We can see that the average race execution time generally increases with increasing week number, which indicates the existence of seasonality in this study dataset. The histogram of race time provides a general idea to the frequency distribution of time for all races in all sections of the route. Typical race time are between 100 and 150 seconds, but there are races that exceed the time by 2 or 3 times. The correlation heat map shows the correlation between the race time on different sections of the route of each section. These are present on the slide. It can be seen that the section 3 and section 4 have a strong correlation, which indicates the unresolved problem of a transport node with high traffic intensity between these sections, which cause delay of the route. A cluster analysis of the data set of the duration of electric transport race in a varied size city is followed. We are using the Cummins clustering method due to its feature of necessary exact distribution of data between clusters. It should be noted that there are several options for selecting the optimal value of the number for clusters K, among which the elbow method and silhouette method and the Kaminsky-Harabash index are most often used. The elbow method considers subjectively understandable graph of the nature of the charge in the scale of points, from the largest value to all points in the one cluster to the smaller value, which is increase in the number of growths, K. These graphs are present on the slide. When clustered the average daily duration of the race for each week using the Cummins method, the results of calculations the number of clusters using the elbow, silhouette, and Kaminsky-Harabash methods were taken into account respectively. K is equal 5, K is equal 2, K is equal 3. Figure on the slide center shows the distribution of data average daily value of the duration of each race of each week during the year into cluster obtained for K equal 2, 3, and 5. Division into clusters using the Cummins method of the average daily duration of each journey by vehicles of each week are presented in the table on the slide. When divided into two clusters, where the value of K is equal 2 was obtained by silhouette method, we have cluster with number 0 and 1. When divided into three clusters, where the value K is equal 3 was obtained by Kaminsky-Harabash method, we have three clusters, and divided into five clusters, the value of which was obtained by the elbow method, we have clusters with number 0, 1, 2, 3. The cluster analyzing of large-scale heterogeneous data set on the duration of electric transport trip within an average-sized city reveals individual section trip zone of the route with different intensity, which are highly influenced by traffic, their location in specific urban areas, city center, residual areas, as well as seasonality. Despite the subjectively of determining of optimal value of the number of clusters using the elbow method, we see that dividing the average daily duration of trip for each week into clusters gave the best result for K equal 5. Thus, it can be started that proposed algorithm for selecting a clustering method based on internal metric for assessing the quality of clustering data collected from the infrastructure of passenger transport by public transport in a medium-sized city is quite simple and effective. The clustering method includes the elbow method, the silhouette method, and the Kaminsky-Harabash index, which allow for a quick and easy selection of the optimal value of the number of clusters, as well as taking into account the feature of the data. The elbow method allows us to take into account the intracrustal general variation of point within a cluster relative to the cluster center. The silhouette method measures how similar the point of the cluster are compared to another clusters, and the highest value of the Kaminsky-Harabash index indicated that the clusters are divided most clearly. As a result of the cluster analysis of passenger transportation in an average size city with a developed public transport network, it was found that the collected data of the duration of each journey by vehicle with each day for each week during the studied period have a complex, heterogeneous, and large-scale structure. Therefore, they require appropriate processing before starting the analysis. We have used the Cummins clustering method since this method, by the reducing the value of the loss function necessary to implement the accurate data distribution in which each object belongs to only one class. A simple and most effective algorithm for choosing a clustering method is proposed based on internal metric for assessing the quality of clustering of data collected from infrastructure of passenger transportation by public transport in average size city. The clustering metric includes the album method and silhouette method and the Kaminsky-Harabash index, which allow for a quick and simple selection the optimal value of the number. The album method allows us to establish the intra-cluster general valuation of point within the cluster relatives to the cluster center. The silhouette method measures how similar the point of one cluster are compared to other clusters, and the highest value of the Kaminsky-Harabash index indicate that the clusters are defined most clearly. Thank you for your attention.